So we have three types of, or two lines can cross. It could be parallel or coincident. And let's see what that basically means. When you have one solution back in Algebra 1 and Algebra 2, we have one solution right there. Do we have the same slope or different slopes? Different slope. And then when two lines are parallel, do they ever touch each other? Okay, and that would be the scenario of they have the same slope, but different what kind of intercept? Y-intercept, very good. And then coincident basically means the line is right on top of the other. So no matter what, it's touching forever. So that would be infinitely many. So it will be the exact same equation. And that's my abbreviation for equation, EQXN. Okay? This is simply from Algebra 1, okay, and 2. So let's see, example number 1. So if we're looking for how many solutions we have, the answer will either be, you'll either say there's one, there's none, or there's infinitely many. So let's kind of see what's happening here. Do I have the same slope? So we have different slopes. So let's look at our condition on the top. If I have a different slope, we have how many solutions? One. That's it. That's all you need to do. You're not solving for it yet. Y'all good with that? Okay. The next one says, how many solutions does the system below have? So again, is it the same idea? One, none, or infinite? Yes? Okay. So then we would have to solve for y on this one. What I want to do on this one will be, let's go ahead and rewrite this off to the side. So we have 3x plus y is equal to 4. To make y by itself, what am I doing on both sides? Subtracting. So we have y is equal to negative 3x plus 4. Good on that so far? Okay. And then for my second equation, the y is almost by itself, correct? What am I doing on both sides to get rid of that 2? Divide everybody by 2. So when I do, I get y now is by itself. What kind of number do I get with the x? Negative 3x plus?
8.
Ooh, not 8. 4. So if I compare these two equations, let's go back up here. We have condition 1, 2, and 3. Same equation. Do we all see that? If it is same, it is what?
Infinite.
Infinite. So I'm going to put my infinite sign. So then for example 3, it's going to involve more work. I'm actually asking you to solve for it. So let's see if y'all kind of recall. Y'all remember substitution? Do y'all remember elimination? Okay, we're going to use one of each. Okay? On this one, it's going to be substitution. When I see y, what can I plug in? All the y will be replaced with x plus 3. Let's go ahead and circle that. Here's my y. So I have 3x plus 4. All of the y is x plus 3. Now from there, can we distribute, combine like terms, and so on? Okay, let's start with distribution. What number am I distributing on both? 4. 3x plus, it'll give us 4x plus what? 12, very good. And then we're going to combine what? Combine like terms. How many is 3x and 4x? 7x plus 12 is 26. And then how am I going to get rid of the 12? Subtract. 7x equals how many then? 14. Okay. And then when I divide, I get x equals how many? 2. Now, when it says to solve, that means I want what is the x value and what's the y value. X is 2. And then we want to plug that back in right in here. So it says x is 2. 2 plus 3 is how many? 5. Is this all coming back to you? You're like, ooh, I miss algebra. All right, let's go on to the back. Okay, on the back, let's practice elimination. So when y or x is by itself, the easiest thing for you guys to do is substitute, okay? Y'all good? Yeah. Okay? If it is not, and they're lined up as x's, y's, and constant, you'll then use elimination. So let's kind of recall elimination. If I have 2x and another positive 2x, are they opposites of each other? No, I need to make one of them a negative. Now, does it matter which one I make negative? Not really. But then when I'm looking at this, I go, ooh, there's one negative, there's two negatives. I think I'm going to take this one and multiply by -1. And as I multiply by -1, I'm going to kind of rearrange. So 2x becomes what? Negative 2x, put that right under. And I'm putting it under the x's, under the y's, and the constant because I'm thinking ahead for elimination. Is everyone good with that? Okay? The next one. The -5y becomes now what? Plus 5y. Again, make sure they all line up. And then I have the -10 becomes +10. Ooh, it's raining. Y'all okay with it? So if you chose to eliminate the first one, it's okay. But I chose the second one just because my brain says so. Okay? But we'll get the exact same answer. So now let's go ahead and go for this. What is on the left with the x's that I have? It looks like a 3. That's a 2, by the way. Positive 2x and -2x. What happens to them? They're gone. Poof. So now I have -3y and 5y. When I combine, is how many? 2y. How many is 9 plus 10? 19. That's a little bit annoying, right? So we have y is equal to, this one is going to be what?
8, 9.
I think I'm going to leave it as 19 over 2. Now, if that is bothersome and you're like, I want to say 9.5, is that right? 9.5? That's okay. So now to plug it back in. Which original equation looks easier? The first one? So I'm going to plug this one in right here. So we have 2x minus 3, plug in the 19 over 2, is equal to 9. And if you're having a hard time with the fractions, let's practice. 19 times 3. Can someone just get that right off the bat? I think of 20 times 3 and take 3 away. 57? Someone say 57? So we have minus 57 over 2 is equal to 9. And then we're going to add 57 over 2 on both sides. 57 over 2. Now, let's rewrite the 9 with the 2. What is 9 represented with divided by 2? 18, very good. So that means I'm going to cross this off and say, hey, I'm not using you anymore because I want to combine like terms with common denominator. So we have 2x is equal to, what is 18 plus 57? That'll be 60, 75. Anyone see 75? Okay. So we have 75 over 2. And then we're going to divide it by 2. So watch what I do on this one, though. Would you agree if I multiply by 1/2, this all becomes 1? Oh. Did y'all hear what I just said? If I take the 2 and multiply by 1/2, what is half of 2? 1. Do I get 1x? I do. So that's going to give me 1 over 2 right here. And all I have to do is that goes away. X equals 75 over 4. So our order pair, this is very ugly. I'm not going to give you one ugly like this. But it is a good practice, okay? If you have good number sense, that shouldn't be a problem, okay? If your summer was really long, it could be a little intense. Okay, let's go on to example number 5. Can we do elimination again on this one? Yep, there's 2 options here. I can either make one of the x's negative, or I can either take this y and multiply by 3. What do you guys prefer? Worry about the negative, the x? Okay. Should I change the first one or second one? Second one, okay. I'm having you tell me what to do, huh? So now x becomes negative. What happens to my y now? Positive. What happens to my 8? Negative 8. Let's see if this one is neater. Does the x go away? Okay, that's nice. How many y's now? 4y is equal to 4. Ooh, this is nice. I like this one. Okay? So as a group, it doesn't matter which original you plug it into, but it has to be either this original or this original. Plug in the y, tell me what the x is. Someone said 9? Do we agree?
Yes.
So we have 9 comma 1. Okay, for number 6, can I use substitution? Isn't y equal y? So can I say 3x minus 8 is 4 minus x? Let's do that. So we have 3x minus 8 is equal to 4 minus x. I like to move the smaller x. Move this x on both sides. 4x minus 8 equals 4. What would I do on both sides from algebra? Add 8. That's going to give me 4x is equal to 12. Ooh, is it clean again? We are very happy. 12 divided by 4, everybody? 3. Somebody plug in the 3 into one of the originals and tell me what the y is. Ooh, is it negative 1?
Or it's just 1.
It is positive 1. So we have x is 3, y is 1. So y'all okay with 5 and 6, right? 4 was ugly. It is a good practice on notes. Number 7. All right, Ian, let's read number 7, please.
The perimeter of a rectangle is 40 meters. The length is 1 less than twice the width. Find the length and width of the rectangle.
Okay, let's start with the picture. So it says the length is 1 less than twice the width. So if I call this one x, 1 less than, how do I write 1 less than in algebra 1? Minus 1 at the end. Twice its partner means 2x. Do we all see that? Okay? So you can write that all around if you want to, but here's my logic. How many of this x exists? Here and here, so I'm going to say 2x. Plus, how many of this exists? 2. And then open your parentheses because we have to distribute. What was a whole perimeter, it says? 40. Okay, let's do our tedious algebra. We have 2x. And then distribute. 4x minus 2. Combine like terms. 6x minus 2 is 40. Move the 2 over by adding. So we have 6x is equal to 42. Is that a clean number? Okay. X equals how many? 7. It says to find the length and the width. So 7's one of them. So if I plug the 7 back into this x, 2 times 7 minus 1 is how many? 13. Here's how you check. Y'all ready? We have 2 7s. How many would that give me?
14.
Okay, think of 14 in your head, okay? We have 2 13s. How many is that? 26. Together is?
40.
Was that the perimeter given to us? There's always a way to check.